Warm welcome to all of you. Today we will discuss about the concept of learning by rote in machine learning, complete analysis with real world examples. Now, what is learning by rote in machine learning? Learning by rote in machine learning means memorizing data without learning patterns or rules. Memorization, it is different from learning. In this approach, the model simply stores exact input to exact output pairs and recalls them during prediction without understanding any relationships between features and labels. There should be an exact match between input to output pairs. The model can predict correctly only for inputs exactly match the training examples. Even a small change in the input causes incorrect predictions because the model lacks the ability to generalize from past data. This approach fails on unseen data and is not considered true machine learning algorithm. Since real-world applications require models to adapt and make predictions on new data, learning by rote is viewed as an inefficient and incorrect learning strategy. So here in this case, we are trying to develop a few algorithms exactly which match to a specific problems. This tells us a particular algorithm, it cannot be generalized to different problems. One particular algorithm can be specifically designed for a specific problem. That particular algorithm will work for that particular problem only. So therefore, here it must match for exact input to exact output pairs. I will show you one simple example over here. Password based login system. The system allows access only when the entered password exactly match the stored password and cannot handle any variation. So here exact input must match with exact output. So that's how the password must match with the existing password. Otherwise, that particular algorithm will not work out for any other algorithms. So real-time examples, online banking login systems reject access if we even one character is incorrect. So we have to enter exact login credentials whenever we want to access the banking account. Even Wi-Fi router allows connection only when the exact password is entered. If at all, if we enter at least one character wrongly, that particular Wi-Fi connection we cannot access. College ERP portal deny login if case sensitive is changed. Example, even case sensitive, capital A and small a. So for here, what exactly expecting a specific algorithm, it is specially designed for a specific problem. That algorithm will work for that particular problem only. So here input to output exactly must match. The second one is voice assistant with fixed commands. The assistant responds only to predefined voice commands and fails when the same request is spoken using different words. So here voice based assistant. Early voice assistant responds only to commands like call John but failed for make a call to John. So exact words and exact voice intensity must be matched. So similarly, barcode scanner. The scanner identifies products only by matching stored barcode patterns and cannot recognize damaged or new barcodes. So exact input to exact output match must be there. So that's the reason why this is the concept of memorization, not the concept of learning. Here we are not trying to predict something or we are not trying to generalize something here. We are trying to match the exact input to exact output. The real-time examples, supermarket billing counter failed to scan torn or faded barcodes. Warehouse inventory scanners reject newly introduced products until barcodes are added. Library barcode system fails if barcode stickers are scratched. And similarly, exact match search engines. The search engine retrieves results only when the query text exactly matches indexed keywords. The real-time example, file search in older operating system finds results only for exact file name. But nowadays with AI-enabled search engines, can able to fetch the data very easily, even with a minute matching data also. But in the older search engines, the keyword must match exactly, then only that expected file will be retrieved. Database keyword search files if spelling or word order changes. So early website search tools returned no results for synonyms. And similarly, template-based chatbots. The chatbot gives responses only for stored questions and fails to reply meaningfully to slightly modified questions. College admin chatbots responses only to exact FAQs. Customer support bots fail if users rephrase questions. So here in all context, what we can able to understand, a specific algorithm, it's specifically designed for a specific problem. So whenever a particular input exactly match with the existing data, then only we can able to access that particular output. So it's not like training and testing concept. Here it is exactly memorization philosophy is applicable. The next one, OTP verification system. The system accepts only the exact OTP sent to the user. Even a small change in the digits leads to a rejection. The system does not infer or correct mistakes. It relies purely on exact matching. Similarly, pattern-based CAPTCHA systems. CAPTCHA accepts only the exact pattern or characters shown. Slight user variation causes failures. So in all circumstances, in all situations, what we can able to understand is a specific algorithm. It is specifically designed for a specific problem. That a particular algorithm, it specifically works for that particular problem only. Similarly, rule-based attendance system also. In example, the Irish scanning, right? Every individual will have their own, Irish data. So the scanner will recognize only for that particular ID only. Fixed format online examination system. Nowadays, we are trying to run with this rote learning. Keyword based resume screening or the examples of this rote learning. So in all circumstances, what we can able to understand is uh, a specific algorithm which has been written very specifically for a specific problem. So it's not like machine learning. It is just the extent of training only, but the exact input must match with the exact output. So what are the certain key characteristics of learning by rote in machine learning? The model memorizes training example instead of learning patterns. But learning patterns, dividing the total data set into train data and validation data and testing data, these things will happen in machine learning. But in rote learning, it will not happen like this. Predictions are correct only for input seen during training. It must match with the input data to output data. There is no generalization to new or unseen data. Uh, but for unseen data, generalization will happen in machine learning. The model lacks reasoning and adaptability. High training accuracy, but poor performance on test data. So therefore, rote by learning by rote in machine learning, it explains very clearly, but the model simply stores exact input to output pairs and recall them during the prediction process. Unless if there is no match between input to output pairs, the particular model cannot run. So this is what the concept of this rote learning in machine learning.